Alright, so today we're looking at what we term variable forces. So again, remember Newton's law that we're looking at, the resultant force is equal to ma. So if we've got a force that varies, then we're going to have an acceleration that varies as well. And so then we've got these particular expressions for acceleration in terms of some calculus or some derivatives, derivatives, I guess you probably should call those, shouldn't I? But in terms of calculus, these are all different expressions depending on information that we've got that we can use for the acceleration. Alright, so let's have a look at some examples. So first example here is we've got an object and it's got a mass of 10 kilos. Initially at rest, acted upon by a force F equals T, bracket T minus plus 1 Newton, between 0 and 5 seconds. And we want to know the speed after 4 seconds and the distance travelled be in that 4 seconds. Alright, so up here we talked about rest, so we know T equals 0, U equals 0, so we may need to use that. And let's have a look at what else. Alright, so the other thing we've got is this force expression, and that's in terms of time. The force is varying, so the force is T squared plus T, if we look at it in that way there. Alright, so with Newton's second law that we talked about up the top there, that the excuse me, the resultant force is the mass times the acceleration. So if the resultant force is this expression, so 10A would be T squared plus T. And so A then would be T squared plus T on 10. Alright, so what do we want? We want to know, first of all, the speed after 4 seconds. So I'll do that over here. So the speed or the velocity is if we anti-differentiated the acceleration with respect to time, and we've got an expression for it over here. So of course I can take the 10th out, and so we've got T squared plus T. Not equals anything. T squared plus T dt is what I should have. And so what we've got then is 1/10 of T cubed on 3 plus T squared on 2 plus some constant. Alright, now we need to find out what that constant is, and that's what we came up here initially at rest. So T equals 0, V equals 0. And so you can put those in, and 0 equals 1/10 of 0 cubed on 3 plus 0 squared on 2 plus some constant, and so our constant is 0. So now we therefore have the expression for velocity, and expression for velocity is simply 1/10 of T cubed on 3 plus T squared on 2. Make that bracket a bit longer. Okay, so what do we got? So we'll find the speed after 4 seconds. So the speed after 4 seconds, that would be when T equals 4. When T equals 4. And so I just need to substitute 4 in. 1/10, 4 cubed on 3 plus 4 squared on 2. And according to my notes, when we work that out, that becomes 2.9 3 meters per second. All right. Now, when we have a look at this, the next bit, it says find the distance travelled. So we've got an expression for velocity here. And so we could draw, if we wanted to, we could just do a rough sketch of a velocity time graph. And so if v equals 1/10 of, it's the wrong one, this one's the expression I'm after, not the one that I've substituted. So the 1/10's out there, but you notice t squared is common there, so I can go t squared on 10, t plus 1. So that tells me I've got a repeated factor here at 0, and at t's minus 1 down here it's going to cut through, so it's a cubic of course. Repeated factor's turning point, there's no negative, so it's a normal one, so it goes like this particular one. Now of course we're told only look between 0 and 5 in that restriction up there. Alright, so it holds between 0 and 5. And so in part B we're after the distance travelled. So the distance travelled in 4 seconds. And so here's 4 seconds. And so the distance travelled of course would be the area under the graph, because to get our position we've got to integrate the velocity. Alright. So what we can do then to find the distance that it's travelled, to find that area, we can say then that the distance travelled is simply the area, which is the integral between 0 and 4 of 1/10, put the 10th out the front. Oops, I forgot my, oh no, that's right, sorry, I'm rabbiting on about different stuff, which I haven't got that right, because that's cubed under there, and that's half under there, so this here I said was 1, it's not, it's t on 3 plus a half equals 0. So t on 3 is a half, negative half, so t is negative 3 over 2, so it's negative 3 over 2. But regardless of me making that error by not transcribing correctly, it's still in the negative and we don't need to worry about it, and so we're still just looking at that integral. Now what I was going to say before I saw my error was this particular part of the graph, it's always above the axis, it doesn't go underneath the axis, so we don't have to worry about splitting it into 2 and ignoring any negatives, because again we're talking about the distance, not the displacement, the distance that it travels. So no sign in that, it's the actual physical distance that it's moved. Alright, so now because t cubed on 3 plus t squared on 2. Alright, so what are we going to do then? We're going to go 1/10 of t to the 4 on 12 plus t cubed on 6. Okay, so remember, increase the power by 1, divide by the new power, and we've already got numbers down there, so we need to multiply them together. And then we'll go 0 to 4 of that. And so what do we got? We got 1/10 of. Alright, when we stick 4 in, we got 4 to the 4 on 12. Let me put that up there, 4 to the 4 on 12 plus 4 to the 3 on 6 minus, well, that's 0 plus 0, isn't it? So we don't need to worry about that bit. because that's going to be 0. So in the end, we've got 1/10 of that 4 to the 4 on 12 plus 4 to the 3 on 6. And according to my notes, when you get your calculator and work that out, you get 3.2 metres. Alright, that's not the only way that you could have done that. You could have found the expression for position. But regardless of that, in this case here, just looking at that area, and so just a rough sketch is handy, because what if it went down underneath the graph? Then we'd have to interpret that a little bit differently. Okay, the next one, example I've got here. Particle mass 3 kilos moves in a straight line. Time t, its position relative fixed origin is x, and its speed is v. If the resultant force is 3 plus 6x, and v equals 2 when x equals 0, find v when x is 2. Alright, so in this case, our force expression is not in terms of time like the one that vary with time, but varies as how far away from it is from this origin. Alright, so again, Newton's second law, resultant force is mass times acceleration, so the mass is 3, acceleration's a, we've got 3 plus 6x, divide everything on both sides by 3 and you get 1 plus 2x as the acceleration. Alright, so we're talking about, we want v here. We've got x, and so what we want is the expression with v and x in it. So let's have a look up here, way back up, there we go. So we're looking for expression with v and x in it. This one here, we need to know the velocity of a particular time, and then there's this one here on the end. So that is the one that I'm going to use. So d dx of a half v squared. So let's shoot back down. Alright, so d dx of a half v squared is the acceleration, and so d dx of a half v squared is 1 plus 2x. So if I want to find v, I need to anti-differentiate or integrate with respect to x. When I do that on both sides, the left hand side I just end up with that, and the right hand side 1 plus 2x dx. Alright, so then I've got a half v squared equals x plus raise the power by 1 divide by the new power. Now the new power is 2, so I'm going to end up with x squared, because it'll cancel with this 2 that's already there, and then I've got some constant which I need to find out. Now we were given some information. It says and v equals 2 when x equals 0. So x equals 0 and v equals 2. So a half times 2 squared equals 0 plus 0 plus c. 2 squared is 4, half of that is 2, so c is 2. So the expression I now have for velocity is x plus x squared plus 2. I've just written that in an awkward order there. Convention would have us putting the x squared at the front, wouldn't it? Alright, so now let's have a look. Find V when x is equal to 2. Alright. Find V when x is equal to 2. Okay, so when x equals 2, a half V squared would be 2 plus 2 squared plus 2, which would be 2 plus 4 plus 2 is 8, times both sides by 2, that's 16 for V squared. So then V would be, then when we've got to square root that to get V, because we've got V squared, would be plus or minus 4 would be the answer. Alright, so now we've got to have a look and see what we can do, what we can have a look at. Now, let's have a look. So here, our acceleration, so we've got our acceleration here, 1 plus 2x, alright? So it depends on x. Now we're here, we're going from x equals 0 at the start to x equals 2. So between there and there, 0 and 2, x would be positive. So if x is positive, then this expression for the acceleration, x is a positive number, times it by 2, that's positive 2 still, and then add it to 1. So that's indicating that, but acceleration equals 1 plus 2x, which is positive for 0 less than or equal to x equal to 2. So if that's a positive, that means, what does that mean? That means that the speed is increasing. Alright, and now if the speed is increasing, then what we had at x equals 0, we had it as a positive 2, and it's increasing. So if it was at positive 2 and it's increasing, that means is 4 meters per second. I am guessing them. Oh, and yeah, we did get up the top. We did have units in the question that were mentioned to us. No, we didn't. So just work in what we call MKS units, meters, kilograms, seconds, unless we're told otherwise. So 4 meters per second. Okay, so hopefully all of that makes sense. I did fluff around a little bit in a couple of spots. So if you need some clarification, make sure you get it. And as always, have fun.